Hey, thanks for joining me. We're going to go over the Unit 8 test that you guys finished last week and just walk you through some of the solutions. So we'll start with this first question here from this part 2, question number 7, secant of theta over the tangent of theta. And I have in the corner here the bits that I'm going to use for this one. And the method I'm going to use for this first question, the first one's fairly simple, is to replace each term, each trig function, with its equivalent in terms of cosine and sine. So, for example, the secant of an angle is equal to 1 over the cosine of that angle. So I'm going to rewrite this as 1 over the cosine of theta. And that's already part of an angle, part of a fraction there. So the denominator for that fraction, the tangent, also has an equivalency here. That's the sine of theta divided by the cosine of theta. And we can see that that is really just two fractions being divided. That's 1 over the cosine of theta divided by the sine of theta over the cosine of theta. So we don't necessarily need to write that down to recognize that. We would be wise to write down what that equals, which is a multiplication problem, 1 over the cosine of theta times the reciprocal of the tangent, which is the cosine of theta over the sine of theta. And now we can start doing some work here. We can cross cancel the cosine, and we're left with 1 over the sine. And then at that point we need one more piece from our notes, and that's this, that the 1 over the sine of theta is equal to the cosecant. So this is the cosecant of theta. Remember, theta is just like a variable, like x, representing the angle we're talking about. In all of my identities that I put down as little helps on the side, I use the letter A. It would be more traditional if I'd used a Greek letter alpha, but I find A is easier to write. Okay. So for question number 2 here, we have the sine squared of theta plus secant squared of theta plus the cosine squared of theta minus the tangent squared. That's an important thing to notice. And what this should make us think of is those Pythagorean identities. I've written the two relevant ones down here at the bottom. Sine squared plus cosine squared equals 1, and then 1 plus tangent squared equals secant squared. Notice we have a secant squared, and we have a minus tangent squared. So is there any way to rewrite this last identity to kind of represent what we have there? Yeah, we can take and subtract tangent squared from both sides of that identity, and we'll end up with 1 equals secant squared of A minus the tangent squared of A. Okay, and then we recognize that we have that, secant squared minus tangent squared. All we have to do is reorder these. So I'm not even going to write them down. I'm just going to say, okay, let's just move the sine squared plus the cosine squared next to each other, and that will be equal to 1. And then we'll rewrite the secant squared minus the tangent squared next to each other, and that, when according to this sentence down here, is equal to 1 also. So we have 1 plus 1, which is 2, and there we go. Let's try number 9 here. So we have sine x plus sine x times cotangent squared of x. And again, I've given you the relevant identities, the ones that I'm going to use down here in the corner, but normally we would have a list of, I think we learned 32 identities that we would just have in our notes and need to puzzle out which one we're going to use. So this is the way I think about it, and there's a second way to do this problem, and I think I'll do that on the next slide. But the way I think about it is, as I'm looking at this, I see there's two things being added. There's the sine x plus sine x cotangent squared x. So there's two things being added, and they both have within them the sine x. So if I take out or divide out that sine x, that's the distributive property, if I divide out sine x, then what's left over? And what's left over is sine x divided by sine x is 1, plus sine x cotangent squared x is just cotangent squared x. So I undistributed, and I distributed out the sine x, and I'm left with 1 plus cotangent squared x. Now, seeing that should remind me of those Pythagorean identities. And in fact, we have the third one. We looked at the first two in the last problem. The third one right here actually says 1 plus the cotangent squared is equal to the cosecant squared. So we'll just rewrite this as sine x times cosecant squared of x. Okay, now that we've done that, well, what is the cosecant? The cosecant we have as our identity there is the reciprocal of the sine, so it relates to sine. That's going to be handy. So we'll write sine x, I'll write it as a fraction, times the reciprocal. This is the cosecant squared, so it's going to be the 1 over the sine squared of x. And if you think about that, cosecant squared just means cosecant times cosecant. If the cosecant is 1 over sine, then that would just be 1 over sine times 1 over sine, which is 1 over sine squared. So that works out okay. Now we can cross off the sine x in the numerator, and one of the sine x's in the denominator. There's two of them down there, remember? Sine x squared, or sine squared x. Okay, and that's going to leave me with 1 on top, and just a single sine x on the bottom. And that, of course, is the cosecant function, is the reciprocal sign. So we'll rewrite that as cosecant x. And there we have it, as simple as we can get it. Let's do that one again. So the exact same problem, I'll do this one fairly fast. The exact same problem, but what if I didn't factor out the signs there? What if I just said, well, you know, cotangent, got a cotangent, next being multiplied by a sine. There's kind of a relationship there. Remember that the cotangent is just the reciprocal of the tangent function, and the tangent is sine over cosine. So we could actually rewrite those two together as the cotangent is the reciprocal of the tangent, which would be cosine over sine. And that is actually one of our 32 identities, so we do have that one in our notes somewhere. Okay, so I'm going to take that cotangent squared, and I'm just going to replace it with the cosine and sine, but of course they have to be squared, so we'll rewrite this all. Sine x plus sine x, better put that over 1, times the cotangent squared is cosine squared x over sine squared x. Okay, and we can see this situation again where we have a sign being multiplied by a fraction with a sign squared in the denominator. We can cancel out one of the signs from that denominator there. So that second grouping there of fractions becomes just cosine squared x over 1 times sine, which is just sine x. So notice in the numerator we have cosine squared, the denominator we have sine, a single sine x. And you would think that would be a problem, but here we are over here. We've got to remember that we are adding that, right? We have a plus sign here, and we're adding it to this number, which is not a fraction, but we could make it into a fraction. And oftentimes when always when we're adding fractions, we want to get those denominators to be the same. So if I just multiplied that by the denominator of the other fraction, so now the denominator is going to be the same. Sine x times sine x. Yeah, so multiplying those together, we end up with that first term, that first number becomes sine, if I can write it, sine squared x over sine x. And there's a plus sign. And so now we have two fractions. So we're adding something together here. We're adding something together from the very beginning. Now we're adding those two somethings together. And those two somethings are both fractions and they both have the same denominator. So we're good to go. We're golden. And it just so happens that the numerators are sine squared x plus cosine squared x, which is our Pythagorean identity that equals 1. So I didn't write that one down, but you remember sine squared x plus cosine squared x is equal to 1. So the numerator is 1. The denominator is just our common denominator, which is sine x. And of course, from the last problem, the reciprocal of the sine function is the cosecant. So there we go, we have the same answer that we got before, only we went in a completely different direction to get it. So that's pretty interesting. Well, I'm going to stop here for this recording and we'll finish off the rest of the questions on a few subsequent recordings.